nth term divergence test. In the series sigma an, the term an is called nth term. So this theorem said that if the limit of the general term, the nth term, is not zero, then the answer of this series doesn't exist. So it's infinity or it's not infinity, and that's not a number. So the inverse of this theorem is not correct. So if this sigma, for example, equal infinity, so maybe the limit will be zero. So we cannot say that the inverse is correct. Okay, the inverse is not correct. For example, we can take sigma 1 over n from 1 to infinity. So here, we can prove that the answer here of this sigma is infinity, but the limit of 1 over n when n goes to infinity, the answer is 0. So this is an example of series where this sigma an diverges because the answer is infinity, but the limit is 0. So this is number one. Number two, if I take any sigma, for example, sigma n plus 5 over 2n minus 1 or plus 1 from 1 to infinity. So the answer, so this series diverges using this theorem, the nth term divergence test, because the limit of this term, so this is correct because the limit of n plus 5 over 2n plus 1 equal 1 over 2, because here 1n over 2n when n goes to infinity, and this answer is not 0. So using the theorem, this series diverges. Let's take some examples. The first example, if I take the limit of this term, the limit of 12n plus 5 over 3n plus 1, when n goes to infinity, so it's 12 over 3, so it's 4, it's not 0. So using nth term divergence test, this sigma will be infinity. The series diverges. The next exercise, here I don't have the general term, the nth term. So let's find this here, 1, 2, 2, 3. So it's sigma n over n plus 1 from n equal 1 to infinity. So what is the limit of n over n plus 1 when n goes to infinity? It's 1. It's not 0. So using the nth term divergence test, the answer of this sigma of n over n plus 1 from 1 to infinity will be infinity. The last example. It's not the last example, okay? Here, you know here that the limit, you know the answer of this sigma because this is geometric series. From 0 to infinity, it's 1 over 1 minus a half. So it's 2, 1 over a half. Remember that. Let's remember the rule. Sigma a power n from n0 to infinity, f a between -1 and 1. So the answer of this sigma, it's 1 over 1 minus a. So this series converges, but the limit of 1 over 2 power n, the nth term, when n goes to infinity, the answer is the limit of 1 over 2 power n when n goes to infinity. So 1 over infinity, so it's 0. Okay, so this is an example where uh, the limit is 0 and the series here converges. But the next exercise, this is the last exercise now, we will see that uh, the limit of 1 over n equals 0 when n goes to infinity. But we can prove that this sigma will be infinity. Let's prove that. So this is 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8 plus 1 over 9 plus without stop to 1 over 16 plus 1 over 17, etc. So here I will take 4, 8, 16. So each term 2 power n. So this is bigger than, this sum is bigger than, I will use this idea here that this term 1 over 3 is bigger than 1 over 4, and 1 over 5 bigger than 1 over 8, 1 over 6 also bigger than 1 over 8, etc. So this sum is bigger than 1 plus a half. This is without a change. Now plus 1 over 4 plus 1 over 4. This is a half also, like this term. Plus here 1 over 8 plus 1 over 8 plus 1 over 8. Because 1 over 5 bigger than 1 over 8, 1 over 6 bigger than 1 over 8, 1 over 7 bigger than 1 over 8, and 1 over 8 without change. So this is also a half. Plus, using the same idea, would be also the half. So I will have here 1 plus a half, it's 1. So here it's 1, and these two half will give me 1 plus 1 without stop. So this is infinity. So this series is bigger than infinity. Because it's bigger than infinity, so it must be infinity. So in this example, we see that now sigma 1 over n from 1 to infinity, the answer is infinity, but the limit of 1 over n is 0. So this shows that in our theorem in the beginning here, if the limit is not 0, so it diverges. But if it diverges, we cannot say that the limit is not 0, because in the last example, 1 over n, it diverges. Sigma 1 over n diverges here. We proved that it's divergent, it's infinity, but the limit of an or 1 over n, it's 0.